In this video, I'm going to prove the following trig identities. Prove the following identity. Okay, so normally what you want to do is look at the side that's the most complicated. As it turns out, both of these sides are equally the same, so I'm just going to start with the left side. I believe the trick to this one would be to replace the two terms on the left with their Pythagorean identities. So here are the Pythagorean identities on the right. Let's replace cosecant squared with 1 plus cotangent squared. Likewise, let's replace secant squared x with tangent squared x plus 1. So now let's simplify, drop the parentheses, and distribute that negative through the second parentheses. From here, we can cancel out the 1's, and we've proved the identity. Problem 2, prove the following identity. On this one, the left side is more complicated than the right, so that is a good side to start on. On this one, you might notice that you could factor out a sine squared on the left side, so let's do that. You might notice the 1 plus tangent squared x in the parentheses there is part of a Pythagorean identity, so let's replace that with that identity. We can replace 1 plus tangent squared x with secant squared x. You probably remember that secant x is the same thing as 1 over cosine x. So let's replace secant squared x with 1 over cosine squared x. Okay, let's simplify the left side, multiply those together. Sine over cosine of x is the same thing as tangent of x. So sine squared x over cosine squared x is tangent squared x. So we've just proven that identity. Problem 3. I suspect on this one, thing to do is to multiply by the conjugate, which is 1 minus cosine x over 1 minus cosine x. The reason for doing this is we can make a Pythagorean identity substitution in the denominator. I'll show you here. Okay, so let's simplify and multiply on the left side. So there's the new numerator. Then for the denominator, you want to do FOIL. So you want to do first, outer, inner, last. So first, 1 and 1. Outer, negative cosine x. Inner, cosine x. Last, negative cosine squared x. Right, so let's simplify the left side. In the numerator, you can factor out a sine squared, and then in the denominator, you'll notice that the negative cosine x plus cosine x goes away. So you're just going to be left with 1 minus cosine squared x on the bottom. So now we have that Pythagorean identity in the denominator, so let's make a substitution. So here's that Pythagorean identity on the right side there. So let's move the cosine squared on the right. So then sine squared x is 1 minus cosine squared x. So we're going to make that substitution. So now we can cancel the sine squareds. And we've just proven the identity. Problem 4. So again on this one, I would start on the left side because it's the most complicated. So let's get a common denominator on both of these fractions. Let's multiply the first one by sine x over sine x and the second fraction by 1 plus cosine x over 1 plus cosine x. So I multiplied the numerators out and I got sine squared, and I just left the denominator factored. For the second fraction, I have to do FOIL for the numerator, and I'll just leave the denominator factored like I did for the first one. So again, FOIL is first, outer, inner, last. 1 times 1 is 1. 1 times cosine x is cosine x. Cosine x times 1 is cosine x. Cosine x times cosine x is cosine squared x. So I'm going to replace the numerator, which is the product of those two, with this. And again, I'm leaving the denominator factored. So let's add these two fractions together now that they have the same denominator. From here, you might notice a Pythagorean identity in the numerator, sine squared plus cosine squared. So I'm going to replace the sine squared x plus cosine squared x with 1. Now we can combine the 1 and the 1 to make 2. Factor a 2 out of the numerator. We can now cancel the 1 plus cosine x out of the top and the bottom. So after we cancel the 1 plus cosine x's, this is what we have on the left side. So we have the 2. So somehow we need to convert the 2 over sine x into 2 cotangent x secant x. Let's try converting cotangent and secant into cosines and sines. So cotangent is cosine over sine, and secant is 1 over cosine. So let's try manipulating this a little bit and see if we can get it to look somewhat like the left side. So it looks like all we need to do is multiply the left side by cosine x over cosine x. Then we can just manipulate this a little bit so that the cosine in the numerator is over the sine and the cosine in the denominator is by itself. So we're kind of working in reverse from what we did on the right there. So then we just proven the identity.